Well, good afternoon or morning, depending on where you are. I'm going to discuss a little bit about water sampling, just the general practices that I've seen out in the field, and what we've done in workshops up and down the West Coast, and then move into some of the data aspects in the second part of this presentation. So a little bit, Don's already touched on a lot of this, a little bit about the Food Safety Modernization Act with respect to Subpart E, the water requirements. There's a couple of things that you've probably been, well, probably in the last 3 years beat over the head with, but there are certain things that if you don't know, you should know or start focusing on at this point, even though they are re-looking at the rule in general. But in general, they think what we have heard, and this is all conjecture, is that there will be some type of sampling. Now, what that looks like, we'll wait on the rule, and then when that comes out, Dr. Harris will get that information out to you guys. What is agricultural water under the rule? It's water that's intended to or likely to contact the harvestable portion of covered produce. The rule is going to require that you do a source inspection. So what we call a system inspection. So where you take your water, they expect you to sort of walk around, free it from debris, get things in order for you to take a representative sample of your water that you're applying to crops. They're going to have you establish a water quality profile and update that annually. And what that looks like, again, is in the air, so we won't focus on that. And they really want growers to focus on sampling around harvest. So again, that's a sort of subjective term within the rule, but what we talk about today, if you want to know more, in the preamble of the rule under Subpart E, the FDA goes through a painstaking process of answering every question. So, and you can read them all. We've read it all. Everybody on this webinar has read those. It takes a while, so get ready to sit down and read a lot. Again, Don mentioned that the compliance dates are probably going to be shifted, but as it's written now, they will start with larger farms begin next year, early next year. And we don't know what the rule is going to look like. So, but it's a good idea for you guys, if you haven't started looking at your water sources, to start looking at them, clean up around the areas, and start sort of getting prepared to take water samples at your source. Again, and what struck us, and I'll talk about the data that sort of helps this process, is that large operators, we noticed, had the potential, were on the hook for hundreds of samples. So we really wanted to, we at the Western Center wanted to look at that and try to reduce that burden, and I'll talk about it here in a little bit. So taking a water sample, the number one thing we say is don't complicate it. Taking a water sample should be simple, and I'll show you some practical things you can do that will keep you from overcomplicating it. This is the number one. Be prepared to take a water sample. That means getting certain things in line for you to take a water sample, getting your equipment ready to do it. And it shouldn't be, if you're a large grower or you're a small grower, it shouldn't be farmed out to just anyone. Training is important. If you haven't taken the PSA training, they go through that too, the Produce Safety Alliance training, and other types of GAPS training to take a water sample yourself. If you're doing it yourself, now, there's the caveat. Aseptic technique, that means just keeping everything clean. Using proper aseptic technique is just keeping everything clean. And then labeling clearly so that you know what's written on the bottle and what's written on the form that goes to the lab. And the lab, if they can't read it, they can and sometimes throw those samples out if they can't read your documentation and document everything. The one thing about FSMA is that you're going to need 3-ring binders. You're going to need to put all this information into a 3-ring binder so that when there is an inspection, that you have that prepared. And so that's something that's the least of what you need to worry about. And growers have a lot to worry about. So water quality in the West, in my opinion, isn't one of them, and it shouldn't be. Sending the samples promptly to the lab, I'll get into the data that supports that analysis, is that when you take the sample, you should take care of that sample, get it on ice, and get it to the lab as quickly as possible. And again, recording results clearly, that's number one. That's why I say it twice in here is record your results and label clearly. So there's not a whole lot you need to take an aseptic water sample. You need clean gloves. Now that's taken out of the box, not the one that's in the side door of the truck. But taking those clean gloves out of a box, putting them on. Now, will they keep you from contaminating your sample? Absolutely not. What we tell growers in our workshop is that it prepares you to take a sample. This is what I'm doing right now. I'm not going to do anything else like read a book or get my lunch out and start eating my lunch with my clean gloves on. You ready to take a water sample? That's all you should be doing until that bottle hits the cooler. Sample bottles, now if your lab doesn't provide them, you should get sterile sample bottles. You can use, some people ask me about the sodium. When they get their sample bottle, if they lose that little tablet, they come with a little tablet. It's sodium thiosulfate, and we'll talk about that here in a minute, but it's a little sodium thiosulfate tablet that neutralizes halogens or chlorine. So if you lose it, don't sweat it, but try and keep that in there. It does preserve the sample a little better. A sampling pole, if you're doing surface water sampling, a sampling pole is important. I've got mine here. I always do. This is an extension pole. I made this myself. This is a Home Depot special. Not that I'm Home Depot or Lowe's, whichever one you prefer, or Ace Hardware. It's preparing to take a sample safely, is having that. You don't need to wade into the water to get the sample. So, and also alcohol prep pads. Now, if you're doing piped water sampling, alcohol prep pads are your friend because you need, and I'll explain the process here in a second, but you need them to clean the spigot or whatever the sample point is. And then a cooler. A hard-walled cooler is the best. If you're using cardboard, it needs to be insulated, styrofoam insulation or something like that, but a hard-walled cooler is the best because it keeps ice, keeps it longer, and it protects the sample to the lab, all the way to the lab. Now, what you take your sample in, it always depends. Now, we use, in the lab, we have used everything from these Whirl-Pak bags, the little bags that you whirl and that you close up and you send to the lab. You can use that, perfectly appropriate, or a hard container like this amber bottle here that protects it from sunlight. Not necessary. You can use like clear bottles. What we don't want you using are emptying one of these out and using these bottles. We never recommend that. Always use a sterile bottle because once you empty that water out, you don't know that you haven't contaminated that bottle. You want to label them clearly and have a sample ID. So where is the sample being taken? If it's spigot A on turnout B, that's what you want to write on the bottle. That way you can always return to that site, even in the pond A on the outtake or intake side. You want to have that sample labeled clearly, your time and date, and who took the sample. So that way you know there's some consistency in who takes the sample, and if it's bad, it wasn't because they farmed it out to someone else to take that sample. You know who is exactly taking that sample. And then again, I mentioned the sodium thiosulfate tablet. While it's a preservative, so you can use it if it's in the bottle. If it's not in there, don't sweat it. So taking a surface water sample, so this could be a river, this could be a canal. You can see me here, and I'll demonstrate this, is I've got the cap secured, got my gloves on, and I'm ready to take a sample. I'm leaning down. This is under the road turnout here, but I take the sample and drop it down into the water column and through the water column and then straight up and then cap it. It's as simple as that. You'd be amazed at how many people mess that up. So, because they'll skim the surface or they'll do other things while they're trying to take a sample. Nope, you just plunge that thing down, fill up the bottle. Now, what you don't want to do is fill the bottle all the way to the top. You want to take the sample and have a little bit of headspace, what they call headspace. So you want some air so that the lab can homogenize that sample, can mix it really well because they need to. If you're getting in a stream, I don't recommend getting in if you don't need to, but if you do need to get in and wade in, the recommendation is to face upstream and take that sample. Give the water column time to settle because you've trudged through there, and then water flowing past, you want to take an upstream sample. The cap is the most important thing. So securing the cap is definitely the most important thing. And we don't recommend, if the water isn't flowing, and I'm not talking about ponds or things like that, I'm talking about stagnated water on your farm. Those are hot spots, generally speaking, because you got people driving through them or farm equipment going through them. Don't take stagnant water samples. It's actually not useful for you. And even if it's hot microbiologically, it really doesn't tell you a whole lot at that point for you. Just near your water source is where the best place to take a sample. Now, taking a piped water sample, if you look at this photo here, we wanted to illustrate there's a lot of things going on here, but there's only one place to sample, and that's that hose right there. And a lot of folks will it's their instinct to just grab the hose and take a sample from the hose. We never recommend taking a sample from a water hose. Remove the hose. You need I would say a metal or some cleanable area, like a spigot, to take the water sample. And what we do is we open it up, we flush it, we flush the system. There's a calculation for that. The National Resource Conservation Service has a calculation to flush your well or the piped water system. Now, if it's a lateral turnout, then there's no way you can flush it. It's just going to keep going. But in a well setting, you'll want to flush it for at least 2 to 5 minutes. Now, if it's housed in something, we don't recommend you flooding the housing. So you just open it up where you're comfortable with flooding, and then closing that spigot, grabbing your alcohol prep pad, and really getting in there and cleaning that spigot, around the spigot inside. And you'll notice, gosh, there's all this gunk on there, and there will be. So then you open it again. You flush it for another 30 seconds to a minute, and then take your water sample, just like you do in a surface water sample. Fill it up, and have a little headspace. Close the bottle, throw it in the cooler. You're good to go. Very simple. Now, this is a story. This is a, quote, professional from a lab that is nationwide, known nationwide. And we happen to be out there teaching the FDA, or at least teaching the FDA, some of the inspectors, how to sample water. And this guy came along very brazenly amongst everyone and took this sample. Now, on the onset, you don't notice anything about it. But if you look, his finger is inside the sample container. He's sampling from the hose. He didn't take the hose off. He didn't clean anything. So all of this. So no matter if you get a lab to take your sample, if they come out and take your sample, it's incumbent upon you to be there, or at least see how they take the sample. Now, they may be sending 7 people out every month, but you at least want to know that they do everything right. And this is not right. This is actually contaminating the sample. We didn't say anything to him. We just let him go, unfortunately. But we did tell the grower at the time, yeah, you need to watch that sample, because you guys pay a lot of money for these samples. I think here in Mississippi, the only lab for a presence-absence test costs the grower $100. So one sample that doesn't give you any result, really, it just gives you, yep, it's there, costs $100. So this is expensive. And if they take the sample, it's even more expensive. Now I am staged, taking initial record-ordering samples. But if you notice, I'm not wearing gloves. That's a no-no. And in both of these photos, I'm not wearing gloves. If you look closely at this sample, there's surface debris on this sample. Again, no gloves. My bare hand inside the cap. See that finger sitting over the cap? Yep, that's a no-no. This is the number one thing, getting things right inside the cooler. One, you don't want to put your samples in a cooler like this. This is a big no-no. These are all sterile bottles, but they're all dumped over the ice that can melt, and that water can contaminate inside if you have a loose cap. And so this is why we recommend hard-walled containers. One, they don't leak. We don't recommend ever you put it in buckets or on the side door of a truck. I've seen it at very large facilities. Water sample folks from the farm will throw the sample in the truck and go to the next spot, take a sample. You want to avoid that. You want to use a container that's appropriate for what you're taking a sample of. If you're taking a sample of a dust abatement well and you're letting it pour down on you, you're not going to take this little Whirlpack bag and sit there under it, because I guarantee you, and I've seen, this is all stories, is that the dang bag hits the ground. I've seen the guy pick it back up, take the sample, definitely contaminated. Definitely you don't want to send that to the lab, because you will get a bad result coming out of it. There's optional reference bottle we use as researchers. We use a temperature blank and a field, or temperature blank and a field or trip blank. Those are more expensive because the lab has to process them. But it is a good way to test your lab, is to send sterile water in a sterile bottle to your lab to see if things are zero, because they should be, right? So that's a good way. It's a good thing to use if you, if you're so inclined for the data. This is what a sample cooler should look like. The ice should be, or if you have blue ice, then you can't contaminate it, or you're less likely to contaminate the sample. But wet ice, the ice should be up to the sample level, and the bottle should be upright and not allowed to push over. So any way you can secure those samples is better. So this is data when the rule first came out, everyone was really bent on the hold time thing. So what a hold time is when you take a sample, it's the time from the sample being taken to the time that the lab analyzes that sample. And under the method 1603, and it's been all the methods Don described prior to method 1603 being sort of the gold standard, there was a hold time, and it's generally 6 to 8 hours. So we were like, well, is that actually true in agricultural water? Because generally, you can see there, it's sort of clean. This is an irrigation a ditch from a reclamation district, meaning water returns to the system, tailwater returns to the system. So we wanted to know, is it true? Is the EPA right about that? Well, they are, generally speaking. You start to see declines in bacterial populations at that 6 to 8 hour time. So we don't like to do things just once, so we repeated it. And again, if you look at this, this is these two E. coli, and they're we held it at different conditions. Meaning we put the samples immediately in these conditions from time 0. We processed a time 0 sample, and then we looked at those conditions as they occurred. And so we held it at 4 degrees C, which is recommended. It's 4 to 10 degrees C. We held it on blue ice, so let the ice melt over days, or not melt. Blue ice doesn't melt, but it gets generally warmer. And then we did no refrigeration. And you can see that these conditions are important. You definitely want to be up here in your sampling. So holding it near 4 or 10 degrees C is important, because you keep that level pretty well. But if you look, again, that hold time is important. You start to see very rapid declines. I mean, this is 24, 48, 24 hours. If you're sending this is where you're going to be versus where you actually were. So getting your samples to the lab immediately is the most important thing under our recommendations. So when you get your results, we get this all the time. So what do I need? Well, you need something like this. It doesn't need to be this elaborate, these two, but what you do want to tell your lab when you're bringing your samples to the lab is you want to tell them this is surface water, not drinking water. If you're in the production setting, we're talking about the produce safety rule, but if you're in the production system, you want to tell them this is drinking water, right? You want that equivalent. But if you're sampling water out of a canal, your pond, or your well, you want to tell them it's irrigation water or some other way. And you want to make sure you get a number. A lot of labs, if you send it in there and you get your report back and it says PA or presence absence, that's not going to work. You need a number, whether it's an MPN, which is the most probable number. And that's a calculation. Well, both of them are calculations. One has a higher confidence interval, which is what Don talked about earlier, how they determine these things. The MPN has a higher confidence interval. So, you know, you could be under it or above it, depending on where you, depending on your result. But there's CFU, colony forming unit, what Don talked about earlier. But you want that number. And if you're relying on a municipal water source, some folks are, then you want their municipal report. I just got mine from the city of Mobile, and it said we're less than. That's okay. That's an appropriate number for that, for drinking water. They're under that now. What you don't want is this number right here, TNTC. Too numerous to count. Now, I want to say that the lab was maybe lazy and didn't do a dilution series to get to a number, but you definitely want, if you have a TNTC, you need to resample anyway, but you definitely want a number on those. But TNTC means you have a problem, but you don't know how big a problem you have. And we'll talk about that in a little bit when we get to the data. Okay,